Okay, number 23 is asking for the second derivative. So you find the first derivative like normal, and then when you find the second derivative, there's a first derivative in it. So first, we find the first derivative using implicit differentiation. Negative 4y dy dx. Derivative of 2 is 0, that goes away. And the derivative of 4x squared is 8x. Get the dy dx by itself. We get 8x divided by negative 4y, which is negative 2x over y. It doesn't matter if you put the negative with the 2 or the y, but pick one. Don't leave it out front. That makes you work harder, okay? All right, now we're going to find the second derivative, the derivative of that. So if dy dx is equal to negative 2x over y, then when we do the derivative of that, we're technically taking the derivative of the left side and the right side. The derivative of the left side is the second derivative. The derivative of the right side is a quotient rule. Low, d high, minus high, d low. Draw the line and square below. Now replace this dy dx with what dy dx equals. So we have negative 2y plus 2x. Replace that dy dx with a negative 2x over y. Simplify this. You could have done that at the same time. Multiply that across. You get negative 4x squared over y. And last, you just have to get rid of fractions within fractions like normal. So I'm going to multiply by the problem right here. Multiply by y, and simplify. So when you simplify that, you get a negative 2y squared. The y's cancel, so minus 4x squared all over y squared. So the answer could be that, or they could factor out a negative in the numerator. So you'd have to look and see how it's written, and they left it just like that. Oops, except that I missed a denominator. My denominator was wrong. When I multiplied that by a y, it should have been a y cubed. My bad. Okay, actually pretty easy.